Here we can see what is actually involved in the processing of profiles. The pictures show individual processing stages in an automated factory producing 30 to 60 windows a day. And also, by way of comparison, some work being carried out by hand using simpler machines. The first step is to take a profile which the factory has already covered with a protective foil and to cut it to the correct length using a double miter saw. Alternatively, this can be done in 2 stages with a simple cross-cut saw. First, one end is miter cut, then the saw is turned and a second cut is made to achieve the right length. Here we see the sawing process again in detail. Special routing machines are used to bore drainage and ventilation holes in the frame rebates. The same process can also be carried out by hand. Depending on the static requirements, the profiles might require additional steel reinforcements, which are cut to length using a metal saw. Once this is done, the reinforcements are slid inside the profiles and screwed into place at regular intervals with a pneumatic screwdriver. To enable the fittings to be attached later, groups of 3 holes are then drilled in the sashes, which are also routed as necessary. In this example, the process is highly efficient, thanks to the use of a copy router incorporating a drilling unit. First, the recess for the lock, and then the triple holes for the handle. The triple holes can also be made using a simple upright drill. A key stage in the production of windows using polymer profiles is the welding process. The profiles that are to be joined together are laid in the welding machine, pushed forward as far as the groove and clamped in place. The advantage of using a 2-head welding machine is that 2 corners can be processed at the same time. The profiles are pressed up against the heated flat plate, which is lowered after the appropriate period of time to allow the profiles to be brought together. The actual bonding occurs during the cooling phase, and the profiles emerge joined solidly together. The process is monitored automatically by controlling and regulatory devices. The careful balance between pressure, temperature and timing ensuring a high-quality weld. Here we see the welding process again, this time in greater detail. As soon as the heated flat plate is in position, the melting of the PVC material is clearly visible. The plate moves down and the softened ends of the profiles are pressed together to form a join. Once the necessary cooling time has elapsed, the process is complete and the welded frame can be removed. The welding process can of course be carried out using a single head machine, as in our second example. The welding flash or sprue, which is produced at the profile corners, can be machined off or removed using handheld tools. The individual cleaning operations are being done here without an automatic corner cleaner. The exterior surface of the frame, particularly the area where the fittings will be attached, is cleaned using a small hand router. The groove for the seal is also routed. If a transom or mullion is to be used, the faces must be milled so that they match the rebate of the frame. Holes are made using a jig. Then the connector is inserted and screwed into place. Some of the webs in the front chamber of the profile are removed using a mortise chisel. Matching holes are drilled in the frame. A fixing piece in the frame rebate lends extra stability to the transom or mullion. Next, the transom is put into place. And finally the screws are added to complete the process. Weather seals can be pressed into the frame or sash quickly and easily. When a corner is reached, care must be taken to compress the seal instead of stretching it. A small amount of adhesive ensures that both ends are properly joined. The necessary glazing seals are first cut into approximate lengths, then mitre cut and pressed into place. Frames and sashes can be combined with all the usual types of fittings. Our example shows 2 corner pieces being added and also the sash mechanism. The final fixing is accomplished by means of screws. Manufacturers of other kinds of fittings provide appropriate drilling templates to make them easier to fix to the frame. This is how the templates are used to mount fittings onto the frames. The sash is then hung and the window is tested to make sure it functions smoothly. The glazing beads are cut in basically the same way as the main profiles, preferably with mitered ends. In larger factories, such as the one shown here, the length is determined by means of measuring rods, so the correct cut will be made automatically every time. Two glazing beads lie side by side, and when the saw blade comes across, the next pair is also cut at the correct angle. Although it takes somewhat longer, a cross-cut saw can also be used to cut each glazing bead individually. The glazing operation can be carried out on a table, or more easily, with the aid of a glazing stand. The seals are checked to make sure that they are firmly fitted, and the rebate area is cleaned with compressed air. The mitered ends are sealed with silicone, and the glass unit is then fixed in place with glazing blocks in accordance with the glazing guidelines. The glazing beads are then knocked into place. After a final test to ensure proper functioning, the completed window is made ready for dispatch to the building site.